Greetings, loved ones. Let's take a journey.
Centripetal acceleration. The center-seeking acceleration of an object moving in a circle at constant speed. The formula is A of c is equal to v squared over r, which we simplified into 4 pi squared r over t squared for this problem shown. R was the radius, which was 3 meters in our experiment. Was equal to time it took for the rope to do one full rotation, and this was equal to 2.15 seconds. And the mass was equal to 20.3 grams, but we don't need mass in this equation. So 4 pi squared multiplied by 1 meter over 2.15 seconds squared is equal to 8.53 meters per second squared. And this was equal to the centripetal acceleration of the experiment.
Work it, girl. Come on. Get that down.
All right. The next problem we did was angular displacement. Angular displacement has to do with doors and things and other levers. Angular displacement is the change in the angle theta in an experiment or in a system. These angles are usually measured in radians, pi and pi r, or pi and pi halves. And to find the angular displacement, you use the formula theta final minus theta initial is equal to angular displacement. And for our problem, we had theta final being 90 degrees or pi halves, and subtracted 0 degrees, which gave us pi halves as the final answer.
Angular velocity is equal to the angular displacement divided by the time taken to make the displacement. This is represented by the Greek letter omega. The equation is angular velocity is equal to the change in theta, which is angular displacement, and divided by the change in t, which is time. We had pi divided by 2, theta, and 3 seconds as change in time. So pi divided by 2 divided by 3 equals 0.524 radians per second is the angular velocity of the oven door.
Angular acceleration is a change in angular velocity divided by the time required to make change. The angular acceleration is measured in radians per second squared. And the symbol is alpha, and the equation is alpha equals the change in angular velocity divided by the change in time. Omega is equal to angular velocity, and t is equal to time. In our experiment, the change in angular velocity is equal to 0.524, and the time is equal to 3 seconds. And the angular acceleration is 0.15 radians per second squared.